Welcome to Potentials. Thank you for coming back, everyone. I love that I have these returning people back to my show. Ed Kubersky is back, and thank you for returning. Thank you for being on my show. And you're going to be introducing us to a new person. I mean, I'm going to give the intro, but our new friend, Dr. Brendan Darrer. And I hope I said that right. And I'm going to just give you a little bit of information about him because he's very interesting. He's currently researching integration of vortical motion into subquantum kinetics theory to model quantum particle spin in terms of subparticle units. Other
Yeah.
research activities and topics include astronomy and astrophysics, mathematics, free energy, electrogravitics, mythology, art, consciousness studies, morphogenic fields, holistic physics, philosophy, metaphysics, climatology, transdisciplinary management, and nonprofit organizations. So, wow, that's quite a bit. And thank you for coming to my show. I appreciate having you on.
Thank you very much, Legia.
So, Ed, what would you like to say about this project?
Okay. Yeah, well, Brandon is a friend of mine who it was, I don't know, about 6 months ago, I had the honor of being asked into the Model G Vortical Ether research group, which is associated with the Starburst Foundation. And the Starburst Foundation was started by Paul Laviolette. And Brendan is actually the CEO of the Starburst Foundation as well. So he's also the main editor of the 6th edition of SubQuantum Kinetics. The whole team is working on it, but Brandon is definitely the man. And we're hoping to have a hardcover come out in, sometime, I don't know when exactly, but in the future. The other thing I wanted to say was I did have some contact with Paul Laviolette. I actually said, you, sir, are the second smartest man to set foot on terra firma, of course, Tesla being the first. And my journey started about 6 years ago when I wrote the 80 pages of study notes from Paul Laviolette that had anti-gravity and free energy. And 3 years ago, I released those papers to Elena Denon. She was the absolute first person that got it. And then Dr. Sala got it a couple days later. And these 80 pages of work from Paul Laviolette have been, they've been all over the world, essentially. So in the last 3 years, I've been spreading subquantum kinetics all over the world. So, but I'm really happy to see my friend Brendan here to talk about, we have 14 predictions that come out of subquantum kinetics that over time were proven correct. And these are all from Paul. But we also have another 15 predictions that come out of the superwave theory and some of the climatology part of it that, we'll do a future show with Brendan in the future on. Yesterday in our meeting, we actually talked about and went through some of that stuff for the future shows. So there's actually 29 predictions that come out of subquantum kinetics that were proven over time. And the other thing that people need to understand is Paul Laviolette was a quantum physicist, which is the very, very small. But Paul Laviolette was also an astrophysicist. So he looked at the very, very large planets and such. So between the two disciplines, subquantum kinetics came along, and it essentially is a theory of everything. And it is the best theory that we have. So that's why 3 years ago, I connected with Elena, and who's connected with the Galactic Federation of Worlds. And this is the best physics theory that we have. So this is what we're going to bring to you today. With further ado, I'll let Brandon do his thing.
Okay, thank you very much, Ed and Legia. So I'll just get on with it then. So I should be able to share now.
Yes.
Okay. Okay, so today I'm going to narrate some of the Appendix A of SubQuantum Kinetics, 5th edition, which was written by Paul. And so it's called SubQuantum Kinetics Predictions and Their Verification, written by Dr. Paul A. Lavinet, and I've just edited it. Okay, number 1, nucleon core field, prevailing concept, 1978. The electric field in the core of a nucleon, so a nucleon is like a proton or it's the nucleus of the atom, a proton or a neutron.
Great.
The electric field in the core of a nucleon is assumed to be aperiodic. That means it's not periodic, and to rise to a sharp cusp at the particle center. So here's a picture of, these are the conventional theories. You see that they're rising to a sharp cusp. Okay, so that's the prevailing concept. Prediction number 1, 1973 to 1978. SubQuantum Kinetics predicted that the electric potential field in the core of a subatomic particle should be Gaussian shaped and should continue outward as a periodic field pattern of diminishing amplitude having a radial wavelength equal to the particle's Compton wavelength. So we can see Compton wavelength is basically in the conventional physics, is described as the property of a particle defined as the wavelength of a photon, the energy of which is the same as the rest energy of a particle.
Right.
So having a radial wavelength equal to the particle's Compton wavelength, and that this field pattern should be positively biased in positively charged particles. Prediction published in 1985 and 1995. Verification, 2002. Particle scattering form factor data for the proton and neutron is found to be a best fit by a model in which the nucleon core electric charge density distribution has characteristics similar to those that SubQuantum Kinetics had predicted. Figure 1. So here, this first plot here is the charge density, coulombs per unit volume, the proton. Then we see the surface charge density, and this next one, B, is for the neutron and its surface charge density there. So we're mainly interested in this first one here, because in SubQuantum Kinetics, we've only been able to produce a neutron type of particle, a neutron-like particle. So you can see here it doesn't rise. You can see it has a bell-shaped Gaussian curve, whereas the standard, the conventional model shows it rising, going sharply right up. I'm not sure how high up it goes, but it has a sharp cusp. So the form factor data from the experiment showed that it was closer to a model that James Kelly fitted, which was more like a bell-shaped Gaussian curve. And I think this relates to what Paul had written in his book about classical field theory suffers from an infinite energy absurdity. SubQuantum Kinetics avoids this problem. Particle fields plateau to a finite central value. Also, in general relativity, it is fatally flawed in that it allows the formation of cosmologically disruptive naked singularities.
Yeah.
SQK avoids this problem since particle gravity fields have finite central values. Black hole singularities cannot form. Okay, so this number B here is the charge density, coulombs per unit volume, and it's showing more the internal structure of the neutron. The surface charge is more showing the outward. It's the number of coulombs per unit per distance, per unit distance, and it's showing more the outward oscillatory motion of the outward charge of the neutron. So the energy boosting during collision, however, did cause the target neutrons to exhibit a wavelength slightly shorter than had been predicted. And this is the reference for James Kelly's paper, 2002.
Right.
Number 2, energy conservation and photon redshifting, prevailing concept 1978. The cosmological redshift is conventionally attributed to the assumed expansion of space. Photon energy is assumed to be perfectly conserved. So when astronomers and cosmologists talk about the redshift of galaxies and stars, they're talking about a Doppler shift, like when you hear a siren going no 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 when it goes past it, the wavelengths
Yep.
change as it travels
Yep.
past you.
Yep.
And they attribute this redshift when they observe the frequencies, the spectra from stars that are redshifting. They say this is the galaxies and the stars, they're moving away from us at a certain velocity, and that's causing the redshift. Paul is saying no, that's not what's causing the redshift. The photon is losing energy, it's becoming tired light, and
Tired light,
losing
yes.
energy.
Yep.
So they're saying photon energy is perfectly conserved. Conservation of energy means energy cannot be destroyed. It only transfers from one form to another. So they're saying it doesn't lose its energy. Prediction number 2, 1978. As a basic requirement of the validity of its methodology, SubQuantum Kinetics predicted that photons should gradually redshift with time when passing through regions of less negative or positive gravitational field potential. Field potential just means gravitational energy, newtons per joules per kilogram. In SubQuantum Kinetics is measured as in terms of concentration, number of etherons per unit volume.
Right.
E.g. in intergalactic space, figure 2. So we see here in matter-dense regions such as galaxies or clusters of stars or clusters of galaxies, when photons travel through these, they blue shift. That means they gain in energy.
Right.
And when they travel through galactic voids where there's very few galaxies or stars, they lose energy. And this gaining and loss of energy, so this gaining of energy is to do with the theory in SubQuantum Kinetics of particles producing other particles, or energy coming out of the ether,
Yes.
disobeying the laws of thermodynamics, so similar to the chemical waves of these waves. They create themselves, nothing creates them. And so you see where this energy coming from. It could be coming from the ether, or maybe a higher dimension or something like that.
This very important point. Yeah.
So photons progressively increase their energy within the supercritical G wells of galaxies and progressively decrease their energy in intergalactic space. Prediction number 2, 1978. Okay, so I read that bit. It predicted SubQuantum Kinetics predicted a tired light effect. The distant galaxies should appear redshifted without the need for postulating recessional motion. The galaxies are moving away from us. Verification 1979 to 2021. Laviolette checks this photon redshifting prediction by comparing the tired light non-expanding universe model and the expanding universe model, standard Friedman cosmology, to observational data on 4 different cosmology tests, 1986, and against 8 different tests in 2021. One of these tests, the galaxy number count magnitude test, is shown in figure 3. So I'll just show you that. So I don't fully understand this, but the y-axis is number of galaxy number counts, and the x-axis is apparent brightness, K magnitude. So these are just quantities that you use in astronomy. So what we can see is that the conventional theories don't give such a good fit to the data. You can see the tired light seems to fit the data better.
Yeah, exactly. Yeah.
The tired light model is found to make a closer fit to the observational data on all tests, confirming the SubQuantum Kinetics tired light prediction. and the notion that the universe is cosmologically stationary. So to research up more on this, we look in the SubQuantum Kinetics book. These findings at the same time undermine a key support of the Big Bang theory.
That's a
So
very
Paul
important
is
point.
saying that in cosmology, when they do these different tests, they keep changing the model to fit the different tests. He's saying if they want to change their model, that's fine with me. Be consistent. Don't just change it. Change it for each different test so it fits. So Paul has got one theory, which is the child light subquantum kinetics theory, and he's not changing his model, and it's fitting better the data.
Yeah.
Number 3, energy conservation generation, prevailing concept, 1978. Energy is assumed to be perfectly conserved. Stars are assumed to generate their energy either through nuclear fusion or from heat released from gravitational accretion. Accretion means gaining in gravity, gaining in mass. Planets are instead thought to acquire their luminosity from stored heat. There is no reason to believe that planets should conform to the stellar ML relation, that's mass luminosity relation.
Right.
And Paul, through using Model G and the work of Gemitro and Shriven on reaction diffusion waves as being like photon waves, he derived a model which I'll talk about in a minute. Prediction number 3, 1978 to 1979. As a basic requirement of the validity of its methodology, SubQuantum Kinetics predicted that photons should progressively blue shift in regions of more negative gravitational field potential, e.g. within galaxy clusters, galaxies, planets, and stars. It predicted that genic energy should be continuously created within these celestial bodies.
What is genic energy?
Yeah.
Genic energy is the blue shifting, is basically when there's a lot of matter together. It can appear in galactic voids, but it takes a long time for it to materialize. But when there's matter in subquantum kinetics, matter produces other matter, and matter can produce energy. And if there's more matter, if there's a lot of matter, it can produce a fair bit of energy. Just like I was saying, the energy out of nothing, it's coming out of nothing. It's just coming out of the ether.
Exactly.
Like the chemical waves in like the brusellator, the chemical waves of Model G. These chemical waves, they create themselves. Nothing creates them. They may not fully understand how the process works, but they're breaking the laws of thermodynamics. Laws of thermodynamics say you can't get nothing more out than you put in. You can't get enough. Energy is perfectly conserved. Paul's saying it's not conserved.
Yeah.
Because it's coming from, say, a higher dimension or from the ether.
Yeah.
Okay.
Comes directly from the
So
ether.
when you have matter, when you have a lot of matter, it also produces this genic energy. It produces extra energy, which conventional physics doesn't go there really.
So that's his idea of how the stars work. Is that not correct, Brendan?
Yeah. He's saying a lot of what's going on within the stars is genic energy, and he's using this blue shift, red shift, genic energy to explain a lot of phenomena that conventional astronomy can't understand and gets into a lot of trouble trying to explain. And Paul's been able to explain it quite simply using just this genic energy, this red shifting, tired light, blue shifting.
Yeah. And also our planet works on the same principles. All the planets work on the same principles, do they not?
Of what? The planets produce genic energy, and then stars, mother stars in the center of galaxies, they're producing a lot of genic energy.
Yeah.
And the sun is producing more than, and the Earth is producing a certain amount as well.
Yeah.
Okay. Verification 1979, 1992. Laviolette tested this genic energy prediction by plotting the mass luminosity coordinates of the Jovian planets, Jupiter, Saturn, Neptune, and Uranus. to compare them with the mass luminosity relation for red dwarf stars and found that they conform to this relation. So this relation, which I'm going to show in figure 4, that's the theory. So this theory comes from comes from Model G and the work of Gomitro and Shriven on reaction diffusion waves, which Paul simplifies to the energy from photons, photon waves, energy of photon. So this line is the theory from Model G. So if Model G is correct, these data points should align along this line. So it's not derived from conventional physics, derived from some Model G.
Yep.
Others had not previously checked this because doing so didn't make sense in the context of the conventional astrophysics paradigm. This conformance suggests that the heat coming from the interiors of planets is produced in the same way as that radiating from the interiors of red dwarf stars, just as SubQuantum Kinetics predicts.
Yeah.
We also show that the genic energy hypothesis predicts a slope for the planetary stellar mass luminosity relation. So luminosity is like power, it's joules per second, and mass is just kilograms. So he's just doing a ratio of the mass of the object, the stellar object, over the mass of the sun, and here it's the luminosity of the object over the luminosity of the sun. So luminosity is just like power, it's joules per second. And joules is the measure of energy. So he also showed that the genic energy hypothesis predicts a slope for the planetary stellar mass luminosity relation, similar to the observed flow. So he got this idea from another astronomer and just adapted it for subquantum kinetics. The required violation of energy conservation is 10 orders of magnitude smaller than what could be observed in laboratory experiments. So in laboratory experiments on Earth, like CERN and all these particle physics experiments, that is too small to detect this non-conservation, this energy violation or non-conservation of energy. But on the astronomical level, you can see it much more clearly.
Great.
Okay, so in this plot here, the position of the planet shown in relation to the extension of the lower main sequence stellar mass luminosity relation. Brown dwarfs are also found to lie close to this line. So we've got the Jovian planets here.
Yeah.
And we've got the brown dwarfs here and red dwarfs here. That's the sun. Sun is there.
Yeah, they all fit the slope.
Number 4, brown dwarf stars, prevailing concept 1985. Based on conventional theory, brown dwarfs are not expected to have any particular mass luminosity ratio. They are assumed to be stars that are not massive enough to ignite nuclear fusion, and hence are merely dead stars that are cooling off. Prediction number 4, 1985 to August 1995. SubQuantum Kinetics predicted that brown dwarfs should also generate genic energy, and hence, like the Jovian planets, Jovian means like similar to the size of Jupiter, like the Jovian planets, should lie along the lower main sequence mass luminosity relation for red dwarf stars. This prediction was published on 4 occasions, 1985, 1994, and 1995. Verification, November 1995, 1998. Masses and luminosities are published for the brown dwarfs GL229b and G1963b. Laviolette demonstrates that the mass luminosity data points for these dwarfs lie along the planetary stellar mass luminosity relation, as earlier predicted in figure 4. This indicates that the brown dwarfs are not dead stars as previously supposed, but bodies that are actively producing genic energy in their interiors. So the brown dwarf, so it's the brown dwarf. So there's the brown dwarfs there, the red dwarfs. Number 5, interplanetary maser signals, prevailing concept 1985. Maser signals on what Eddie was saying was microwaves
Yeah,
are
microwave.
believed
Yeah,
Maser signals are believed to maintain constant frequencies over interplanetary distances, since photon energy is assumed to be perfectly conserved. I assume that means the other photons are not supposed to lose energy. I mean, if the source spreads out, then the source is going to seem smaller, but the individual photon, that's what I understand by it. Prediction number 5, 1985. Laviolette determines the magnitude of the hypothetical genic energy photon blue shifting rate by modeling the intrinsic luminosities of the planets. He then predicts that if a maser signal were transponded between two spacecraft, figure 5, so I'm just giving a spacecraft and the Earth, separated by 5 AU. AU is astronomical units. That's the distance between the Earth and the Sun.
right.
The signal should be found to blue shift at a rate of about 1.3 times 10 to the minus 18 per second. This prediction, so that's the rate at which the signal is found, should be found to blue shift to change its fraction at which it changes. This prediction was published on 2 occasions, 1985 and 1994. Verification, October 1998. A group at JPL astronomers published their discovery that maser signals transponded between the Earth and Pioneer spacecraft blue shift at a rate of approximately 2.9 plus or minus 0.4 times 10 to the minus 18 per second. So Paul has said 1.8 or 1.3, sorry, and they're saying 2.9, but it's within the same fraction of 10 to the power of 18 minus 18. Yeah. Although they choose to interpret this as a mysterious force pushing the spacecraft towards the sun, it also provides a close confirmation of the SubQuantum Kinetics prediction. Their value reduces to 2.3 plus minus 0.4 times 10 to the minus 18 per second when the propulsive effects of waste heat from the spacecraft power source is taken into account.
Right.
So Paul's got a figure which is very close to this. Number 6, galactic evolution, prevailing concept, 1979. Galaxies are believed to form in various sizes as galactic size gas clouds gravitationally condense to form stars. The size of galaxies is assumed not to change over time unless through merger. Galaxies in the immediate neighborhood of the Milky Way are assumed to have the same size ratio as young galaxies at cosmological distance. I'm just going to turn on the light. So galaxies in the immediate neighborhood of the Milky Way are assumed to have the same size ratio as young galaxies at cosmological distances. Prediction number 6, 1979 to 1994. SubQuantum Kinetics predicts that matter is continuously created throughout the universe, with the matter creation rate being highest in the vicinity of already existing matter. So even when the universe was devoid of all matter, matter can still be created, but it takes much longer. When there's matter already there, then it's a shorter time.
And this continuous creation is super important to subquantum kinetics.
Furthermore, it predicts that galaxies should progressively grow in size with the passage of time, since they are formed by matter being created primarily in their progressively growing core and being propelled outward by core explosions. Figure number 6. So here we see evolution of galaxies from dwarf elliptical galaxy to early type spiral, mature spiral, and giant elliptical.
Right.
This prediction is published on two occasions, 1985 and 1994. It's a bit like a marathon, this, but I'll keep going.
Yes.
You're great.
Verification, July 1995. Observations with the Hubble Space Telescope show that younger, more distant galaxy clusters are dominated by fainter, more compact galaxies and have much fewer spiral galaxies as compared with nearby older galaxy clusters. There is no evidence that this growth occurred through galaxy merger. So this is the number 7. So he's saying that these in this plot here, it's showing the giant ellipticals and spirals are, there's much more of them closer to us and fewer of them
Right.
further away. So the further away you go is further back in time.
Yeah.
And the blue dwarf irregulars, which are the smaller galaxies, the younger galaxies, there's much fewer of them near us and more of them further away. So when you're
Right.
looking further away, when looking at the light far away, that's further back in time. So percentage of blue dwarf irregular galaxies and peculiar galaxies as compared with the percentage of elliptical and spiral galaxies. Distance, look back, age increases logarithmically from left to right with the increase in apparent magnitude. So I'll just read that one again so I can get it a bit more clearly. Observations of the Hubble Space Telescope show that younger, more distant galaxy clusters are dominated by fainter, more compact galaxies and have much fewer spiral galaxies as compared with nearby older galaxy clusters. There is no evidence that this growth occurred through galaxy merger.
Right.
Verification, 2007 to 2011. Galaxy studies show evidence that the number, count, density of massive galaxies has progressively increased since era Z, or redshift Z equals 3, which is the redshift. So when redshift equals 3, that's closer to us. Redshift, if the redshift is larger, it's much further away. Since era Z, or redshift, equal to 3, with the ratio of massive ellipticals to massive spirals increasing as well. Also, these studies show that the size of the giant ellipticals has progressively increased over time. Also, it was found that the mass density in space of supermassive galactic cores progressively increased since era Z, or redshift, equals 7. So from what I understand by that is that that the giant ellipticals are older ones. So what's it saying? So the ones, so when we look distance and when we look further back in time, the light coming from much further away, you shouldn't have older stars, you shouldn't have older galaxies, because that's much further back in time.
Right.
Number 7, galactic core energy source, prevailing concept 1985. The nuclei of active galaxies and quasars are known to contain central masses ranging from millions to billions of solar masses, and it is assumed that these have collapsed to form black holes. It is further assumed that the prodigious energy output from these cores is powered from matter being swallowed by these hypothetical black holes. No other means of generating energy is known to explain the immense amount of energy observed to come from these locations. Prediction number 7, 1985. SubQuantum Kinetics predicts that matter accreting black holes do not exist. Instead, it predicts the existence of highly massive, very dense celestial bodies of finite size called mother stars, which continuously and spontaneously produce matter and genic energy in their interiors.
Yeah.
These ideas are published on two occasions in 1985 and 1994. Verification January 1995.
A very important one here. No black holes.
Observations made by the Hubble Space Telescope indicate that 11 out of 15 quasars are devoid of any surrounding material, and hence have no matter available to power a black hole hypothetically located at their centers. This supports the SubQuantum Kinetics prediction that such energy sources are instead powered by energy spontaneously created in their interiors. I think he may be saying that quasars are maybe, I'm not 100% sure, but they may be galaxies that are active, that are having galactic superwaves going through them. But I'm not 100% sure on that. Verification September 1997. Hubble Space Telescope observations of the heart of active galaxy NGC 6251 provide further confirmation of the earlier January 1995 verification. These observations show that this galaxy's core is swept clear, and hence there should be no matter available to be accreted. Accreted means gained by the hypothetical central black hole. Number 8, supernova precursor stars, prevailing concept 1985. It is conventionally believed that supernovae are produced by red giant stars, which have exhausted their supply of nuclear fuel. It is presumed that the once red giant's nuclear reactions subside, the star collapses and subsequently rebounds as a supernova explosion. Prediction number 8, 1985. SubQuantum Kinetics predicts that supernovae are produced not by red giant stars, but by blue supergiant stars. That is, by stars that are exceedingly luminous and hence energetically unstable.
Right.
It predicts that rather than collapsing, the star undergoes a non-linear increase in its production of genic energy, which leads to a stellar explosion. This prediction was published in 1985.
Talk about free energy or what, right? There's so much that actually blows the thing up.
Verification 1987. Supernova 1987A is observed in the Large Magellanic Cloud. This is the closest supernova in the history of modern astronomy. Astronomers locate its precursor star on old photographic plates. Surprisingly, they find that this precursor was a blue supergiant star, contradicting established theory and confirming the SubQuantum Kinetics prediction.
Amazing. That's an amazing one.
9. Galactic core stellar masses, prevailing concept 1985. At the time of this prediction, astronomers had not imagined stars in the vicinity of the galactic center, since the observational techniques had not, sorry, I wrote that wrong. At the time of this prediction, astronomers had not imaged stars in the vicinity of the galactic center, since the observational techniques had not yet been developed. Based on their conventional theories, they expected that most stars in the vicinity of the galactic center should be low-mass stars, which they theorized should be very old stars, at least as old as the galaxy, e.g. billions of years. Just wetting my whistle so I can talk better. Prediction number 9, 1985. SubQuantum Kinetics predicts that stars residing in the vicinity of the galactic center should instead be massive. It proposes the theory that matter is continuously created, that stars grow in size and grow most rapidly in the vicinity of the galactic center, where the gravity potential and matter creation rate is highest. As you can see, from a primordial neutron particle, beta decay, hydrogen particle, then a primordial gas cloud,
Yeah.
primordial brown dwarf star, then going on through this creating a solar system, then primordial star cluster, dwarf elliptical galaxy, all the way up to giant elliptical.
Yeah.
Furthermore, SubQuantum Kinetics predicts that massive stars such as blue supergiants are among the oldest stars and are not young stars as conventional theory predicts. Although they pass through this massive stage relatively quickly, ultimately ejecting their stellar envelope. Laviolette published this prediction in 1985 and again in 1994. Also see page 242, last paragraph, of the second edition of SubQuantum Kinetics, which describes the expectation that older, more massive stars should reside near the galaxy's core. Verification 1995. A group of astronomers, Krabbe et al., published observations of the galactic center stellar cluster, which indicate that the region within 1.5 light years of the galactic center is populated with about 24 luminous helium-rich blue supergiants, having masses of up to 100 solar masses. This finding confirms the SubQuantum Kinetics prediction. Unaware of the SubQuantum Kinetics prediction, they have difficulty accounting for this finding. They speculate that these are young stars which must have formed between 3 and 7 million years ago from gas residing in this region, but they're unable to explain how this would occur, since the large tidal shear in the region should have disrupted such a star formation process.
Right.
Verification 2003. UCLA astronomer Andre Gertz reports on observations she made of the galactic center using infrared speckle interferometry and adaptive optics. She was able to plot the trajectories of these stars. Based on these observations, she confirms that the stars in the immediate vicinity of the galactic center within 0.01 light years are very massive, but they have spectra typical of young stars, young by conventional definition.
Right.
She finds this puzzling, since the tidal forces in the vicinity of the galactic center would be much too strong to allow stars to form through a gravitational accretion process. This being especially true of the 8 stars found closest to the galactic center. She suggests that these massive stars may in fact be old stars whose proximity to the galactic center has altered their appearance to make them masquerade as young stars. However, she is unable to offer any mechanism by which this could happen. Here we find her coming close to the SubQuantum Kinetics prediction that these stars near the galactic center should be very massive. However, by following conventional theory, she must resort to proposing mysterious stellar masquerading effects, since conventional theory erroneously interprets massive stars to be young stars instead of old stars. But with subquantum kinetics, these massive stars appear exactly as they should, namely as blue supergiants, which in this paradigm are very old stars. Number 10, gravitational evolution, prevailing concept, 1985. Dwarf ellipticals and giant ellipticals are together considered late type galaxies, while spiral galaxies are considered to be early type galaxies. It rejects the idea that galaxies evolve from one morphology class into another, as Hubble and Jeans had predicted. Prediction number 10, 1985. SubQuantum Kinetics predicted that dwarf elliptical galaxies are early type galaxies, which are in a distinct class from giant ellipticals, which are late type galaxies. It predicted that dwarf ellipticals evolve into medium-sized ellipticals, then into spiral galaxies, which finally evolve into giant ellipticals through a process of continuous matter creation. Verification 2011. A study carried out by Ensler et al. Finds that elliptical galaxies fall into two categories: the fast rotators, dwarf and medium-sized ellipticals, and slow rotators, giant ellipticals. The fast rotators have a well-defined rotational plane similar to spiral galaxies, thereby supporting the SubQuantum Kinetics prediction that such dwarf ellipticals are precursors to spiral galaxies, as Hubble had proposed. Giant elliptical galaxies, which are found to be slow rotators, constitute a distinct class. This supports Sirsik's earlier proposal that they have mass radius characteristics similar to mature spiral galaxies, supporting the SubQuantum Kinetics prediction that they are successors to spiral galaxies. Nearly there, getting. Okay, number 11, gravitational repulsion, prevailing concept, 1985. Electrons are assumed to produce matter-attracting fields, just like protons. Gravitational repulsion is considered a speculative idea. Prediction 11, 1985. SubQuantum Kinetics predicted that gravity should have two polarities, correlated with charge, and that the electron should produce a matter-repelling gravity field. Furthermore, it predicted that monopolar electric discharges should produce longitudinal electric potential waves, accompanied by a repulsive gravity potential component, whose force should scale with the field gradient of the onset of the pulse, published in 1985, 1990, 1994, and 2003.
That's a really important one too.
Verification 2001. Bogdanov and Modenese discover that an axial high voltage electron discharge produces a matter-repelling gravity wave that travels in the direction of the discharge, exerting a longitudinal repulsive gravitational force on a distant test mass, figure number 9. So here we see the Bogdanov's gravity impulse beam generator.
Yeah.
And so there's a high voltage discharge, and it's knocking objects over, going through brick and steel, and knocking a pendulum. I think it can go maybe 200 kilometers away. They demonstrated.
Went through 4 inches of concrete too.
Went through concrete.
Yeah.
So it's producing a gravity wave, a geon field, which is knocking objects over distances. 12.
Gravity wave, very, very important, people.
Gravity wave and Coulomb wave speed, 2003. At the time of this prediction, most physicists and astronomers believed that gravity waves and Coulomb waves should always travel at the speed of light. They also concurred that the force exerted on such waves should scale in proportion to the field gradient. Prediction number 12, 2003. SubQuantum Kinetics predicts that an electron shock discharge should produce coinciding electric and gravity potential waves that travel faster than the speed of light, and that the speed of these superluminal waves at any given point in time should depend on the electric potential gradient of the discharge. This is predicted to be due to the movement of the ether, wind, created by the shocks, the velocity of the pulses being increased by the additional forward velocity of the ether wind reference frame relative to which they propagate. Furthermore, SubQuantum Kinetics also predicts that the gravitational force exerted by such shock waves should increase as the pulse's electric potential gradient increases. Some of this is a bit of a mouthful, but when you listen back to it later, it may make a bit more sense.
And that's faster than light, what they're talking about, superluminal.
Yeah, faster than light. Verification 2005 to 2006. Laviolette worked with research scientist Guy Oblensky to test this prediction with respect to the speed of electric potential waves. Earlier, Oblensky had reported that he had measured the speed of electric shock fronts, Coulomb waves, propagating away from a dome antenna, and found that they traveled at superluminal speed, figure 10. So here's a setup, a figure of the setup. We've got the dome electrodes, antenna, and I think these are certain distances away that they measured. So a test setup used to measure superluminal pulses radiated from a dome electrode. Based on prediction 11, Laviolette theorized that since the shock front expanded radially outward from its emitting dome antenna, its electric field gradient should decrease inversely with increasing distance from the dome, and that the superluminal speed of these shocks should correspondingly decrease inversely with distance from the dome. This prediction was confirmed. They made measurements of the time of flight of the shock pulse to 6 locations of progressively greater distance from the dome and found that the excess velocity of the shock, velocity minus speed of light, v minus c, declined inversely with distance just as had been predicted. This experiment is summarized in chapter 6 of my book, Secrets of Anti-Gravity Propulsion.
Excellent book.
It should be mentioned that Tesla also reported that the speed of his pulses began at a near infinite speed at the dome of his antenna and progressively declined towards c, the speed of light, as they traveled further away.
That's Wardenclyffe. I'm actually an expert on the electronics of Wardenclyffe. So yeah.
Oh, yeah, okay, very interesting. Verification 2008. Prior to 2008, Pogranov had told Laviolette that he and Modernez had measured the speed of the pulses to be between 63 and 64 times the speed of light. In January 2008, Laviolette asked Pogranov whether the concrete smashing pulses produced by the steeper electric field gradients traveled much faster than the pendulum deflecting pulses. Pogranov concurred and said that they had determined that these stronger pulses traveled at least several thousand times the speed of light.
Steeper electric gradient is the key to what that statement there was.
Number 13, so we're nearly finished now. Number 13, dissipative solitons in reaction diffusion systems, 1978 to 1980. At this time, when Model G was developed, no reaction diffusion systems were known that were capable of producing autonomous, self-stabilizing, localized dissipative structures. Prediction number 13, 1978 to 1980. Laviolette develops a bruslator-like reaction diffusion system called Model G as the main ether model for SubQuantum Kinetics. Based on simulation work others had done on the bruslator, he makes predictive extrapolations that Model G is capable of producing autonomous, self-stabilizing, localized dissipative structures, dissipative solitons.
Yeah.
That have a bell-shaped core surrounded by an asymptotically declining periodicity or precise wavelength. So I'll just show you the model G. Yeah, so this is being created out of, it has to be given a 0 point energy fluctuation to start it
Yeah.
off, otherwise it would take forever to do it. But
isn't
so
this your work, Brendan? Sorry to interrupt.
this is the
your
work of
simulation.
Matt Pulver made this. I just run the code that he wrote.
Okay, gotcha.
So we can see that it has a bell-shaped. So we have on the y-axis the potentials y, g, and x. So the y and the x represent the electric field, whose spatial displacement produces the magnetic field, and the
Yeah.
g is the gravitational. So then now potential in electric potential in conventional physics is joules per coulomb, and
Right.
but in subquantum kinetics we're looking at concentration, etherons per unit volume, and the
Right.
x-axis, the x-axis is just one-dimensional space, arbitrary units.
Etherons are very important to all this as well.
Also, he predicted that solitons should be able to bind to one another, spawn progeny particles in their immediate vicinity, and then move when subjected to a concentration gradient. So I'll just quickly get you that to show you that, because that's quite interesting. Let's go to.
And when we talk about gradient, that's just a change in slope. A ski hill is a gradient, if you want to think about it that way.
Sorry?
I was just saying a gradient is a change in slope, essentially.
Yeah, great. So a gradient slope. So higher concentration up here, lower concentration down here on slope.
Yep.
So we can see this. This is in 2 dimensions, soliton
Oh,
particles.
yes.
Now they're not doing everything we want them to do, but they're doing quite a lot of what we'd like them to do. If they accelerate together, they tend to move up like that. But they accelerate, they glue together, and they separate apart. So this is made up of X, Y, and G etherons per unit volume on the y-axis, and 2-dimensional space on the x-axis is 2-dimensional space.
Right.
I can show some other ones.
Is that a simulation that Paul had also developed, or?
That's one that Lumi Pakkanen from Finland, a theoretical physics guy, he produced the simulation, and then he left the group a little while later, and then I did it, and I adapted his code to do that.
Right, the group that we're in, yeah. Gotcha.
So the reason why it accelerates is because we made it fall down a gradient, a G gradient.
Or into the well. Into the well is another way to put it.
So in the 2 dimensions, it's got the part of it's like a G slope. So it's falling down a G slope.
Yeah.
And that's what's making it accelerate. So Lumi Pakkanen wrote the code for that, and then he left a little while later, and I developed it to do the acceleration collision.
Okay, and just for everyone to know that Brandon spent almost 5 years every weekend with Paul in these meetings that we still continue to this day, actually now, right?
Yep. And Paul, he came to nearly all of them, sometimes for 20 minutes, sometimes for 2 hours,
Yeah.
Because he was wrestling with cancer at the time.
Yeah.
So I think he was in a certain amount of pain. But I kept thinking, what's he doing coming to this? Why should he come to see me?
And
anyway.
at the first meeting, I think it was, I met Paul's wife, Mariana, as well, over the Zoom call. Thank you for that, you guys, too. was amazing.
So dissipative solitons that have a bell-shaped core surrounded by an asymptotically declining periodicity of precise wavelength. Also, he predicts that these solitons should be able to bind to one another, spawn progeny particles in their immediate vicinity, and move when subjected to a concentration gradient. 1985, published in 1985. Verification, 2010 to 2021. Matt Pulver conducts 1D computer simulations of the Model G reaction system and confirms that it does produce dissipative solitons,
Yes.
and shows that the resulting solitons have the above predicted characteristics, and that they're able to bond and move, they're able to bond and move in the presence of a G gradient. See Pulver and Labulet 2013. Furthermore, a 2D simulation carried out by B. Darrer, that's me, in 2021, demonstrated the ability of the Model G soliton to accelerate down an imposed G gradient. Besides being the first soliton producing model to be proposed in the literature, Model G may also be the only true, Model G may also be the only true reaction diffusion system to demonstrate the ability to produce dissipative solitons. Okay, now we're on
Yes.
the last one.
Doing great, Brendan. Thank you.
Thanks. Number 14, Galaxy Redshift 1990 to 2021. A larger redshift of Z, so Z is the value of the redshift, that it represents I'll just quickly show you that. So if I look at redshift, redshift is measured in terms of this. It's in conventional physics and astronomy have it like this, and Paul just, I think, gives it a different interpretation. So Z is the measure of redshift, and it's the observed wavelength of the light minus the emitted wavelength over the emitted wavelength.
Right.
Galaxy Redshift 1990 to 2021. A larger redshift of Z indicates a shorter period from the beginning of the Big Bang. The dark age of the supposed Big Bang was when the universe was in a plasma state and did not emit light that ranged from 0 to 450 million years after the supposed Big Bang. Galaxies did not form until 750 million years later, or 1200 million years after the Big Bang, which is a redshift of Z equals 5. Standard, so that we wrote that, and that myself and Justin put that together, mainly Justin, the group.
Yeah.
Standard theory has difficulty explaining the formation of galaxies of Z greater than 5. Concordance cosmology aged 1200 million years after the Big Bang. Since insufficient time is available after the onset of the cosmological dark age, which is said to have begun 450 million years after the Big Bang. As of November 2021, galaxies have been found which have redshifts as high as Z equals 10. Concordance age 470 million years after the Big Bang. Prediction number 14, 1990, 2000 to 2000 and 2021. SubQuantum Kinetics predicts that galaxies will eventually be found with redshifts of Z equal 30 or greater. Concordance cosmology ages of 100 million years or less after the Big Bang. Verification, August 6, 2022. The James Webb Space Telescope, figure 11, has recently imaged the most distant galaxy yet discovered. This one here, I'm not going to read it out. At a redshift of Z equals 16.7. The standard, that's the lambda cold dark matter, Big Bang. Standard lambda cold dark dark matter Big Bang cosmology, which has the Hubble constant as that, and lambda m as that, and,
Yeah.
and so omega m as that, and omega lambda as that, which predicts that the universe began 13.72 billion years ago, maintains that light from this Z equals 16.7 galaxy was emitted around 233 million years after the time of the supposed Big Bang. But really, we should use our reference point, the date of 450 million years, which marks the time of the ending of the Dark Age, when matter was cool enough to form light-emitting stars and galaxies. Yet here is a galaxy which, according to the Big Bang theory, has already become fully formed 217 million years earlier, when matter was still in the plasma state.
Right.
Also, considering that most models require 750 million years for a galaxy to form, the stars forming this galaxy would have had to start forming 500 million years before the Big Bang. In short, this definitely disproves the Big Bang theory. This confirms the conclusion of the cosmology test study performed by Laviolette in 1986 and 2021, showing that the expanding universe theory did not make a good fit to the observational data. Those studies showed that physics of subquantum kinetics, with its tidal-light redshift distance prediction and continuous creation cosmology, instead made a consistently good fit to data on multiple cosmology tests. According to the subquantum kinetics cosmology, a galaxy at a redshift of 16.7, that's what the Z equals, would lie 43.9 billion light years away, which is much older than the Big Bang.
Yeah, exactly.
Okay.
Yeah.
That's the end now. Okay, I'll just go back to...
Oh, thank you.
You survived. Thank you.
A couple things I just wanted to point out. First of all, the supposed Big Bang. I actually remember when we added that supposed in, I think it was a little while ago, into that. There was no Big Bang. SubQuantum Kinetics, there's continuous creation from the ether. And this is literally the blinking universe, or the Turing wave. Every time the Turing wave inverts on itself, it actually is refreshing the universe, if you want to think about it that way. And the other thing to remember, that every single thing in our whole entire universe has one thing in common, and at the very base of it, the building block is that Turing wave. So the frequency of the Turing wave actually is the frequency that our universe is pulsing at. Again, that's the blinking universe. Yeah. So and no black holes, no Big Bang. There's a lot of things that come out of subquantum kinetics that don't agree with what the normal physicists and astrophysicists talk about. But as you can see with these 14 predictions, through time, they came to fruition. And there are 15 more as well, too. So this is a very good indicator that subquantum kinetics is probably the best fit of any physics model that we have at this point. And the Model G part of it, we'll hopefully go through it in more simple terms, maybe in another podcast, Luja.
I mean, we're not saying that subquantum kinetics is everything. It's just
exactly.
a model that seems to predict, to explain a certain amount of phenomena. There's always there's always going to be a better model, or a different model, say the universe from a different angle, you know.
Yeah.
But
it's the best model that we have at this point, essentially, and that's why, you know, in the group we're actually working towards even maybe not improving the model, but adding you know, some things to it as well, because that Justin is the guy that runs the Model G group, and vortical ether, everything has spin, and that's what everybody has to realize. And everything is vibrating as well. And at the very subquantum level, it's vibrating at that Turing level, that Turing wave. So everything in our whole entire universe is continually vibrating and moving. And there is a continuous creation of matter. That's one of the most important things, I think. Hey, Brandon, that comes out of it. What else can you add? I think that you can think of.
I mean, I think it's quite impressive. He hasn't just come up with a theory, and he's actually got a fair bit of evidence that he's on the right tracks.
Yep.
You know, the model hasn't been developed fully, but especially in astronomy. In astronomy, he's got quite a lot of evidence that he's on the right tracks. You know, so it's not just a theory and that's it, and there's no verification of it. He's got all these.
And I can add to this as well, because I personally know Frank Chile, and Frank Chile talks about how back in 1958, I think it was, they were called the G Boys. Literally, they were called the G Boys, and they cracked gravity essentially with modified Maxwell's equations, and that's essentially when anti-gravity was first developed by the military, and at that point it actually went black as well. So electrogravitics and all of that Paul is bringing up is actually was done at Westinghouse by the G Boys back in 1958, but it went black. And now, 6 years ago, I started wrote these papers, and it was just the information needed to get out to the public. And, that's what we're doing now. And again, Model G is the best model that we have at this point. And in the group, we're trying to further develop the model, I guess, is what we're doing, right?
Yeah. I remember one of the main things that the conventional science doesn't have is it so-called free energy or over unity energy. It can't explain it.
Yes.
That doesn't, it can't exist because our theories can't explain it. It's impossible.
Yeah,
And
exactly.
we know Paul saw them working. I've met people who've seen them working. So. And the galactic superwave is another one, which Paul, I think that was his main thing, was the galactic superwave. He thought there was quite a lot of evidence for it, and it could explain catastrophes on the planet from different cycles in the past.
Yeah, climatology and all that, and that's we'll get into that in another show. That'll be the other 15 predictions that Paul Laviolette had come out of subquantum kinetics, that through time, and sometimes it was even 25 years, through time, they all came to fruition. So again, this is the best model that we have, essentially, right, to explain these things.
And Paul said he could explain a fair number of unity energy, free energy devices, but some of them he couldn't explain. But a fair number of them he could explain.
Yeah, so
that's the violations. That's the breaking of the laws of thermodynamics. Thermodynamics says you can't get more out than you put in.
Yeah,
you can't get more out. But Paul's saying you can. You can, from the ether or a higher dimension.
Yeah,
you can draw energy from somewhere from nothing. You can draw energy from nothing, and there's electronics and machines that can tap into the ether or the higher dimensions.
Yeah, so my 80 pages of notes from Paul have been, some people have said that they're most comprehensive, especially when it has to do with the electronics part, notes that there are. And I very specifically went after free energy and how it works. And that's what those study notes are from. And that's actually how I got into the group with you guys. It was an APEC thing that I saw Justin on. I believe you were on it later, but Justin was on it, and I contacted him, and within a few minutes, he actually asked me into the group, which was a real honor to be asked in. I never met with Paul, but you met with Paul for just about 5 years, you said, every weekend?
We started off from about February 2018. We're communicating by email and Facebook. And then around about November, December 2018, we started up the Zoom sessions.
Yeah.
And Paul came to nearly every one. Time to time, he missed out one, but most of them he came to.
Truly
So,
amazing. And Paul again is I nicknamed
every
Paul
Sunday.
Tesla 2.0 because I believe that he finished Tesla's work, because it all has to do with frequency and waves. Essentially, this is a big thing here, and resonance. Resonance is very, very important in all of this, and that's in fact a lot how transformers work. And once you learn how resonance works, your electronics abilities greatly increase essentially at that point. So yeah, so it's been wonderful. Legia, do you have any questions for Brendan or?
No, I just want to say, like, if anyone, any of my viewers are interested in any more information, or if they have any questions, how would they contact you, or should they just leave a comment in the description or in the
Yeah, you can put
in the video?
my email address
Okay,
in there. They
we'll
can
put it in the
contact me, or
description. Yep.
yeah, or I don't know if Eddie wants to put it there. You can put my email address there, and then
Okay.
Yeah, yeah,
Okay,
you can
great.
put mine in. You can put mine
if
in
they
there
want to
too.
join
Yeah,
in or help out, that's great.
yeah,
Right, right.
exactly. Yeah,
So yes, and I'm going to put this on my Patreon as well. I know that I have a lot of people on there that are interested in this. And so I just want to once again thank you, and both you and Ed for coming on and discussing this very important information, and something that I, a lot of people aren't aware of and don't know about. So this is going to be kind of groundbreaking, really, to put this out there.
Hmm.
And I appreciate you doing this. I really do. You're really kind of sticking your neck out, and I do appreciate you doing that.
Thank you,
and
Leisha.
and we, yeah, and thank you, Legia. We really appreciate you having a platform for us to come on and talk about all this
Absolutely.
as well.
Yeah.
Right?
I mean,
Yeah,
this is important work. This is very, very important work, and it needs to
yeah.
be known.
Oh,
It needs to be put out there. Absolutely.
another thing is, sorry to interrupt you. Another thing is
Mm.
that I just remembered in the group with Sam, actually, we're trying to have a simplified version of SubQuantum Kinetics and possibly even a children's book. That,
Awesome.
right? Yeah,
Yeah.
and the Turing wave, which we've done on Legia's Patreon channel. Legia has a Patreon channel. Everybody should absolutely go to it and subscribe, because we talk about subquantum kinetics on there more. The Turing wave is there, and not only that, there are technologies that have come out of this work with Model G and gravity that are like the Hawk, for example, and Chris Beskar from Stavati Aerospace and things. Important to know that Chris Beskar has my 80 pages of Paul's notes, and he also has a copy of New Aerospace Technologies, which was written by Alexander Frolov, the former owner of the Faraday Lab in St. Petersburg, Russia. It's the best ether physics book that's ever been written, essentially. And I was asked to edit it a couple of years ago. So that's important to know that Chris has all this information as well. And Elena Denon and Dr. Sala both
I just need to
have
go to the
said,
bathroom. I'll be back in a few seconds.
oh, okay.
Okay, we're gonna be
Okay, yeah,
we're gonna be cutting this off soon, so because it's been kind of extensive, and I'm sure that that there's some people that need a break.
yeah, for sure, for sure.
But I do appreciate it so much. I mean, really, Brendan has really put a lot of work into this, and the editing of that information must have taken a lot of time and effort, and so I do appreciate
Yeah,
him going to all the trouble of reading it here on my show, and putting that information out there, and then you giving a little bit of background on it,
yeah,
and explaining it a little bit. For some people that this is going to go right over their heads, including me, some of it. That's why I figured, we can include, your information and Brendan's information in the comments, or in the description, I mean, so that people can contact you if they have any questions. And then we can have you
absolutely.
you guys back to maybe break it down a little bit,
Oh, yeah,
put it in
definitely.
in a way that people can, you know, maybe just the average person can understand?
I would like to go through the Model G uh, thing on a whole different program with Brendan,
Right.
because it's essentially the what's most amazing about this is, and this is how free energy works too, is it's just created out of the ether. So these etherons literally just appear, and this is what they don't want you to know. They don't want you to know that this can happen. They don't want you
Yeah.
to know that there is free energy, and the fact that it is actually really easy to do. I've gone through some stuff with Legia and explained some of the ways that you can make these things happen. And in the future, we'll definitely be diving a little bit more into all of that as well too,
Right.
because it's a materials game actually. It's about special materials when it comes down to it, and
Right.
and that's part of the reason why my papers are considered the most comprehensive. And actually, Legia, what's really kind of neat is Justin is the guy that runs our Model G group. He's agreed to use my papers, and it's kind of an honor to have them first used on a chat GPT. So Justin is an AI programmer that wrote AI programs that learned from AI programs. So he's an AI
Right.
programming expert, and
Yes.
he's setting up a special SubQuantum Kinetics, AI for us and the
Wow.
world.
That's
And
cool.
essentially, my papers are going to be the first ones to be used once Brandon deciphers my handwriting, because they have to be. And you've seen that, so
Yes.
um, that's going to be a little bit of a task for Brandon and I to go through that. And yeah, and those papers, we've already done some of it, but we plan on releasing that on her Patreon channel at some point, probably
Right.
later this year. It'll be later on this year sometime when
Yeah.
that gets there. Yeah,
Yeah,
but
that'll be great. And again, I just wanted to throw my appreciation out there to both of you for coming on. And everyone just reach out, put something in the comments if you like this information and if you want to hear more. And again, you can reach out to Brendan and Ed here. And we look forward to talking to you guys again. Thank you for coming on, and ciao for now, everyone.
Thank you, Legia.
bye.